Dear students, welcome to the video permutation. We can make a permutation by taking a number of objects and arranging them in a line. Now, look at this example. You have three letters A, B, and C. And we are going to count all possible ways in order to arrange these three letters in a line. Now, the first one is already written. I write them here, which is A, B, and then C. It is the first case. The second case, I keep A here, then I switch the place of order of C and B. So I write C here, B here. The third case, I can put B here and write AC. Fourth case, I can keep B here, then CA. Now fifth case, I can write C here, then AB, and sixth case will be C at the first position, then BA. There is no other case. As you see, there are overall 6 ways to rearrange these three letters in a row. Now let me put it in this way. Now again, I have three letters A, B, and C. Now I'm going to arrange them in a line. Now I construct a box here including 3 positions. Now, for the first position, in order to put them in these 3 positions, so what I can do first is to choose one of these letters to put in the first position. For the first position, I have 3 options. I can put A or B or C. So I have 3 options to put here. So I write the number of options here, which is 3. Then, as one of them is put here, let it be A. For example, A has been put here. So you have 2 options to put here. So it will be 2 options for here. Then one option has been chosen for this position. One option has been chosen for this position. So definitely one letter will remain to be put here. So then 3 times 2 times 1 will be 6. Or you could say 3 factorial. Now I want to make a conclusion here. Permutation of n distinct objects is n factorial, as you see here. Or you can use this notation, n p n. What does this notation mean? It means that you have n letters and objects. You are supposed to permute them. You are going to count the number of permutations, and you are going to choose all n objects. Why do we put n here? Because in following cases, in following examples, you will see that you have, for example, 8 people. You are going to choose 5 of them to put in a line. You are going to choose some of them to put in a line. But here in this example, you have 3 letters, and all 3 letters are going to be put in the line. That's why I wrote npn. It means that n objects are going to be chosen from n objects. npn, or which is equal to n factorial. Let me write it here, npn. You have this key in your calculator is n factorial over n minus n factorial, which is n factorial over 0 factorial. 0 factorial is 1. Then it will give you n factorial. That's why npn is the same as n factorial. So as a conclusion, so permutation of n distinct objects is n factorial. Example 1. In how many different ways can 5 boys be arranged in a row? As you see, there are 5 objects, 5 boys, and all 5 boys are going to be arranged in a row, in a line. So the answer is 5 factorial, which is 120 ways. Now let me put it in this way again. I want to show in a table what happens 1, 2, 3, 4, and 5. As we have 5 boys and they are going to be arranged in a line, in a row, so we have 5 position here. Position 1, 2, 3, 4, 5 for each individual boy. Now imagine we have 5 boys here. So for the first, I'm going to choose one of the 5 boys here. For example, they are A, B, C, D, and E. For example, boy A, B, C, D, and E. Now, for the first position, I'm gonna choose one of these 5 boys. So I have 5 options to choose for the first position. So one of them, for example, I don't know, B has been chosen. I cross it, B has been chosen. Now I'm going to choose one person for the second position. So how many boys are there here to choose? 1, 2, 3, 4. So I have 4 options here. For example, I have chosen D for the second position. So 2 people have been selected so far. So for this position, I have 3 options to choose. So I have 3 options. For example, I have 3 options. I choose, for example, E. So for this position, now I have 2 options. So then, for example, I choose A here. Then for the last position, I have definitely 1 option. So it will be 5 times 4 times 3 times 2 times 1. Which will be 3 times 2, 6 times 4, 24 times 5, 120. It is the number of different arrangements for 5 boys in a line. Example 2. In how many ways can 9 elephants and 4 mice be arranged in a line? As you see, there are 9 elephants and 4 mice. So overall you have 9 plus 4 objects, which is 13. So these 13 objects is going to be arranged in a line, which is 13 factorial is the answer. Or you can write 13 permutation 13, because 13 objects out of 13 objects are going to be selected to be arranged in a line. They both give you the same answer.